Hello, friends. I hope you all are doing good. So, in this lecture, we will study the fourth unit, which is data preparation phase to model the data. In this unit, we'll learn how to partition the data in Python and how to balance the training data set and how to build card decision tree using Python and how to build C 5.0 decision tree using Python and how to build random forests in Python. Okay, so let's begin our video. Okay, so data preparation phase to model the data. Data preparation is essential before training a machine learning model as it ensures that the data is clean, balanced, and ready for the algorithms to learn effectively. Proper preparation improve model performance and helps prevent issues such as overfitting, which is the model learns too much from the training data and performs poorly on new data, and underfitting, which is nothing but the when the model fails to capture the underlying patterns in the data. Okay, so let us now we'll start with the partitioning the data in the Python. Let us take an example. Imagine we have a data set containing customer information like age, income, education, and credit score with the target variable indicating loan approval, saying yes or no. We will use this data to walk through various data preparation steps. Partitioning the data in Python. Partitioning the data involved splitting the data into training sets and the test set. So we basically divide the whole data set into two sets. The first is training set and the second is test set. The training set consists of 75% of the data and the remaining 25% is consist for the test form. The the training set is used to train the model while the test set evaluates its performance on unseen data. Our goal is to use the training set to train the model and test the set to assess its performance. Now, we'll first import the pandas libraries and then from sklearn dot model selection, we'll import the method train test split, which will use the train test split method will just split our data into two sets, which is the train set and the test set. And then the last library, random. In this example, we will partition the bank traditional data set into training and tests using Python goal machine learning to evaluate the model performance on unseen data. Step 1 is importing necessary libraries. First, we need to import the required libraries. We will use pandas for data manipulation and train test split from sklearn to split our data set. Step 2 is loading the data set. Next, we will read the data set into a pandas data frame named bank. Make sure to replace the file path with the actual path where your data is stored. Like you can see, read in bank additional data set, the panda pd.read csv, we have copy the path of the file, which is the bank additional.csv. The step 3 is partitioning the data set to partition the data set into training and test sets. We will use the train test split function. This command creates two new data sites, bank train and bank test. So we have data, original data set bank, and now it will convert into two sets. The first is bank train set and the second is bank test set. Partitioning the data set, bank train comma bank test equal to train test split equal to bank test size equal to 0.2, random state equal to 123. So you can see the train test split method is converting the bank data set into two, which is bank train and bank test. Bank, this is the original data set we are partitioning, and the test size is zero point 0.2. This parameter indicates that 25% of the data should be allocated to the test set and the remaining 75% is allocated to the training set. Random state equal to 123. This parameter sets a seed for the random number generator, ensuring that the split is reproducible. Step 4 is confirming the partition. To confirm that the data set was partitioned correctly, we can check the shapes of the original data, set the training set and the test set. So first we have print the original data shape of bank dot shape and then training the shape of data set bank train, and then printing the data set of bank test. So by this we can check the shape of the original data set and then the respective splitted data set, which is bank train and bank test. The output will give you three tuples. Each tuples contain two values, the number of rows and the number of columns. The first number from the bank train.shape and bank test.shape outputs should sum to the first number of the bank.shape dot output. The first number from the bank test.shape output should be approximately 25% of the first number from the bank.shape output. For example, if the original data set has 1000 rows, the expected output should be bank.shape should be 4000 comma x, where x is the number of columns, and bank train.shape should be 750 comma x. Bank dot test shape should be 250 comma x. This confirms that 750 plus 250 equal to 1000, which is the total number of rows. 250 is 25% of 1000. Now we'll coming to the second part, how to balance the training data set in Python. Step 2, data balancing problem. Our data is uneven. More no reject and less yes approve. If we train the model like this model will be biased and will reject more. The solution to this is we will unsample the minority class approve customer so that the both the classes approve and reject become equal. Let us understand this through a code. We are from sklearn.utils, we are importing resample, a function for unsampling. And now we have made two classes, majority class and minority class. As you can see that the loan rejection is more than the loan approval because the no of the loan is in the majority class and the yes of the loan approval is in the minority class. So first we'll unsample the minority class equal to, we'll use the resample function and which we have put minority class and replace equal to true and n samples equal to length of majority class. It will just convert both the minority and majority class to the equal range. And now we'll use the PD method to concat the both the data, both the class, which is majority class and minority class, a function to combine both the data set. Now we'll new class balance check. We have used the print balance train target dot value counts. First, we separated majority class loan reject and minority class loan approve. Then we unsampled minority class so that it becomes majority winning. Then we combine both the classes and create balanced data. Now we'll move to the third topic, which is how to build card decision tree using Python. CART, classification and regression trees, is a decision tree algorithm that can be used for both classification and regression tasks. It constructs binary trees. Each node has two branches by splitting data into subsets based on the feature that results in the best separation according to a criterion. In this case, we have used Gini index for classification. Gini index in itself is a wide range of a topic. CART classification is a popular decision tree algorithm. It splits data into subsets based on the feature, providing the best separation measured by the Gini index. Let us take an example, predicting loan approval based on the customer information. We have to import first the necessary library, which is sklearn.tree, and from that we are importing decision tree classifier. Now, how to train our decision model. Initialize the model with Gini index as the splitting criterion. We have used cart model equals to decision tree classifier. And in this, we have given criteria equal to Gini and at the random value, which is 123. And we have used the fit method on our data set, which is X balanced and Y balanced. This is the name of our data set. Now, this is the method used to make predictions and evaluate. We have used dot predict method and applied it on X test to make some predictions. Now, building C 5.0 decision tree in Python. The C 5.0 decision tree model restricts the tree depth, example, max depth of fire to prevent overfitting. This control ensures the recapture general patterns with excessive detail. Now we'll set the maximum depth to avoid underfitting. C50 model equal to decision tree classifier. We have given criteria equal to entropy, and we have set the maximum depth equal to 5 and the random value which is 123. Now, we can also train our model by using fit method and providing our data set which is X balanced and Y balanced. Now, we can also make some prediction. For that. We can use our dot predict method in the 5.0 model and put it in the data into a variable prediction. Now, coming to the last topic of our video, which is building random forest tree. Random forestry builds multiple different trees and combines them for robust prediction. Because it is a multiple different tree, this approach reduces overfitting while improving accuracy. So this is better than the our decision tree classifier because it reduces overfitting and at the same time improving the accuracy. First, we have to import the random forest variable from sklearn.ensemble and the numpy. Now, we have to convert the target variable into a one-dimensional array because we want to make multiple different trees. For that, we need our data in one-dimensional array. For this, we have used the Ravel method in the our Y data set and initialize and train the random forest model. RF model equal to random forest classifier and estimators equal to 1000, and we have given criteria equal to Gini. That the same we have given in the above codes also, and through the fit method we have used X balanced and Y balanced of array. Just remember to keep your target variable into one dimensional array, and we can also make the predictions just like we did above by importing sklearn.matrix import accuracy score, and we can print our random forest accuracy and our classification report. Okay, so this is all from this video. Thank you for watching. Bye.